Now let's see how to solve a question when we have a supernode. Supernode is formed when there is a voltage source alone connected between two non-reference nodes. When you look at this question, if we follow the same steps that we have learned so far, we first need to identify nodes. So node is a place where you have more than 3 branches connected. So here we have a node, another one, and here as well. So then the next step is for us to assign voltages to these nodes. Consider one node as our reference node and assign 0 voltage. So this is our reference node and this is 0 voltage, and we can assign voltages V1, V2 and V3 to other nodes. We have a supernode here because in between V2 and V3 we have a voltage source alone, so that is a supernode. But again, with this reference node and in between the reference node and the V1 we have a voltage source alone, but this one we don't consider as a supernode because supernodes formed when there is a voltage source alone between two non-reference nodes. So here this voltage source is between the reference node and another node. So this 10V is like this, we don't consider as a supernode. Here the supernode, when we have a supernode, we consider this V2 and V3, making the supernode including the V2 and V3 together. So this one together we call it a supernode. When we have a voltage source alone between the reference node and another node, we can find out the node voltage here. For example, in this case, V1 is equals to 10 volts. Why we call it 10? Because in this voltage source we have a negative at the bottom and plus at the top. So the top voltage is higher, so that will be 10 volts because the bottom voltage is 0. In case if we have this voltage source in the opposite direction, plus and minus in opposite directions, for example here if we have negative here and positive here for the same 10, then our V1 is a negative 10. So you already can find out when there is only a voltage source between the reference node and another node, you already know that node's voltage, so that won't become a supernode. Now let's see how to solve the question. So when you have a supernode, so what are the things we know? So we already know that V1 is equals to 10 volts, and this supernode, we just keep the voltages as V2 and V3 at the two sides of the supernode, but we know that is a supernode. When you have a supernode, you can write the equation for the voltage. So if you start from V3 minus, you go in this way, V3 minus 5 minus V2 is equals to 0. I told you when you're going from this side from towards the left, you are starting from the starting voltage and you are minusing the voltages along the way, and when it goes to here you can say it is equals to 0 because you're starting from 0 and going to 0, so it is 0 here. Like you can say this voltage from here to here is V2, from here to here is V3, so this is plus and minus, so you are applying the KVL along that loop. So here you can find an equation, V3 minus V2 is equals to 5 volts. So this is, you can write this equation to a supernode, and this is one equation you have, and also you know this one, V1 is 10 as well. So those two, let's leave it like that and we apply the other steps for a supernode. So I'm deleting these things to make the slide clear. Okay, now we assign currents to all the branches. So I have assigned I1 current here, I2 current here, and I3 current here, and I4 here. Now if you write the KCL to the supernode. We don't write the KCL to V1 separately, so V2 separately and V3 separately. We write it to the supernode. So whatever the current coming into the supernode equals to the current going out. So in this case, we have I1 coming in and I4 coming in. So we can say I1 plus I2 is equals to, sorry, I4 is equals to I2 plus I3. Now we write the voltages. So I1 you can write as V1 minus V2. So that means 10 minus V2 over the resistance, which is 2. I4 you can write it as, so I4 coming from here to here. So starting from V1, which is 10, and going to V3. So V1, or else I can say 10 minus V3 divided by the resistance along that path, which is 4, is equals to I2, which is V2 minus 0. So we can say V2 over 8. And then we have I3, which is V3 minus 0 over 6. Now we have an equation with V2 and V3, so we can solve, we can simplify this one first. So we get the common denominator 8. So 4 times 10 minus V2 plus 2 times 10 minus V3 is equals to V2 plus, we can't take 8, 6 times 24, maybe we need to take 24 as the common denominator, sorry about that. So let's take 24, 12 times 10 minus V2 plus 6 times 10 minus V3 is equals to 3V2 plus 6, 4 times V3. Okay, let's simplify this equation. We have 120 minus 12V2 plus 60 minus 6V3 is equals to 3V2 plus 4V3. Let's find V2, make the V2 the subject in this case. So we can say we take the V2 to right hand side. So 15 V2 is equals to 120 plus 60, so 180 minus 10 V3. So we can divide by 5. Okay, we make the V2 the subject. So V2 is equals to 180 minus 10 V3 over 15. We can further simplify this. So we found V2 in terms of V3. And we wrote another equation considering the V2 and V3. So that was V3 minus V2 is equals to 5. So again we can say V2 is equals to V3 minus 5. So with these two equations, so we have two simultaneous equations, we can solve these two and we can find V3. So when we find the V3, let's find the V3. So I'm going to write it somewhere here. So we can say V3 minus 5 is equals to 180 minus 10 V3 over 15. So I'm going to delete all the unnecessary equations from the slide. So we can say 15 V3 minus so here 5 times 5 is 25, 5, 75 is equals to 180 minus 10 V3. So we can say 25V3 is equals to 180 plus 75. So you can find V3 here. So you find the V3 and you can substitute it and you can find V2. V2 is equals to V3 minus 5. So you can find V2 and V3 both. After finding V2 and V3, you can find the current. So we already know current I1 is equals to V1 minus V2 over 2. So 10 minus V2 over 2. And current I2 is equals to V2 over 8. We already wrote this. Voltage divided by the resistance will be the current. And I4, you can write I4, which is V1 10 minus V3 over 4. And you can write I3, which is equals to V3 over 6. So you know the voltages V1, V2, V3, and also you know the currents I1, I2, I3, and I4. So we apply the same steps that we have applied for the normal node, question using this normal node procedure. However, whenever you have a voltage source between two non-reference nodes, you need to consider that as a supernode, and we write the KCL to the supernode. So that's the only difference here. So you can see it in a better way here. So this is the same thing I have explained to you. Current coming into the supernode is equals to the current going out from the supernode. So I1 plus I4 is equals to I2 plus I3. So I1 we can write as I1 starting from V1 and going to V2. So it is V1 minus V2 over the resistance, which is 2. And I4 is V1 minus V3 over 4, because I4 is starting from V1 and going all the way up to here. And I2 is equals to V2 over 4, V2 over 8, sorry, so this one branch. And I3 is V3 over 6. So we have those. We already discussed that. Then I explain you how to get an equation for V2 and V3. So we can write the KVL for that particular loop, and you can say V. So you start at this point and you're going this way. So it is a negative V2 plus 5, because going into the positive side of the 5 and going into the positive side of the V3. So that will be negative V2 plus 5 plus V3 is equals to 0. Actually, when I was explaining the question, I took the current in the other way, but we still got the same equation. So I considered this way current. So that's why I said V3 minus 5 minus V2 is equals to 0. So you still get the same equation here. It doesn't matter which direction you consider the current is flowing, you still get the same equation. So here you can now see the solution. So V1 is 10. We already know how we got the 10 for V1. And we have two simultaneous equations. So we solve the two simultaneous equations and we can find the V3 and V2. So you can try this question now. The only difference is you have a dependent voltage source in the supernode. You can try this and I will explain this in the next recording.